Section 701.11 of the National Electrical Code, NEC, addresses connections permitted ahead of the main service disconnect. The information provided does not specify distance limitations for this tap. It's crucial to understand the implications of tapping ahead of the main service disconnect, particularly in emergency systems. These systems often require a reliable power source independent of the normal supply. Tapping ahead of the main service disconnect allows certain loads, like emergency lighting or fire pumps, to remain operational even if the main service is interrupted. However, this practice is subject to strict regulations to ensure safety and prevent overloading. The absence of explicitly stated distance limitations within the given text highlights the importance of consulting the authority having jurisdiction (OJ). The AHJ is the local governing body responsible for interpreting and enforcing the NEC. They may have specific requirements or interpretations regarding distance limitations based on local conditions and installation practices. Factors that might influence distance limitations could include the size of the conductors used for the tap, the ampacity of the overcurrent protection devices, the type of loads being served, and the overall design of the electrical system. It is necessary to determine whether or not those factors should affect the distance limitation of the tap. The NEC provides general guidelines for electrical installations, but it's not intended to cover every possible scenario. The AHJ has the authority to make informed decisions based on their expertise and knowledge of local conditions. When planning a tap ahead of the main service disconnect, detailed engineering calculations are essential to ensure that the system can safely handle the intended load. These calculations should take into account voltage drop, conductor ampacity, and short-circuit current ratings. Voltage drop refers to the reduction in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail prematurely. Conductor ampacity is the maximum amount of current that a conductor can safely carry without overheating. Selecting conductors with adequate ampacity is crucial to prevent fire hazards. Short-circuit current rating refers to the maximum amount of current that a component or system can withstand during a short-circuit fault. It is important to select components with appropriate short-circuit current ratings to prevent equipment damage and ensure personnel safety. In addition to consulting the AHJ and performing engineering calculations, it is also important to carefully document the design and installation of the tap. This documentation should include detailed drawings, specifications, and test reports. Proper documentation can help to ensure that the system is installed correctly and can be easily maintained over time. Regular inspections and testing of the tap are also important to ensure that it continues to operate safely and reliably. These inspections should be performed by qualified electrical professionals who are familiar with the NEC and local regulations. Here are some additional considerations related to tapping ahead of the main service disconnect. Firstly, coordination of overcurrent protection. The overcurrent protection devices protecting the tap and the main service must be properly coordinated to prevent nuisance tripping and ensure selective clearing of faults. Secondly, grounding and bonding. Proper grounding and bonding are essential to minimize the risk of electric shock and ensure the safe operation of the electrical system. Thirdly, labeling and signage. The tap and all associated equipment should be clearly labeled and signed to identify their purpose and function. Fourthly, accessibility. The tap and all associated equipment should be readily accessible for inspection and maintenance. Fifthly, compliance with other codes and standards. The installation must comply with all applicable codes and standards, including the NEC, local building codes, and any other relevant regulations. Consider a situation where there is an emergency generator. Tapping ahead of the main service disconnect might be necessary to supply power to essential loads during a power outage. In this case, the transfer switch should be located as close as possible to the generator to minimize voltage drop and ensure reliable operation. Furthermore, it's important to consider the impact of the tap on the overall reliability of the electrical system. A poorly designed or installed tap can create a weak point in the system and increase the risk of failure. By carefully planning, designing, and installing the tap, and consulting with the AHJ, it is possible to ensure that the system operates safely and reliably. Emergency systems also require regular testing and maintenance to ensure they are ready to operate when needed. These tests should simulate power outages and verify that the emergency loads are being properly supplied by the tap. The results of these tests should be documented and any deficiencies should be promptly corrected. Furthermore, the location of the tap is important. It should be in a location that is protected from physical damage and environmental hazards. The tap should also be accessible for inspection and maintenance. The specific requirements for the tap will vary depending on the application and the local regulations. It is important to consult with a qualified electrical engineer or contractor to ensure that the tap is installed correctly and meets all applicable requirements. Remember, safety is paramount when working with electricity. Always follow safe work practices and consult with qualified professionals when needed. Here is a more detailed explanation of some of the considerations mentioned earlier. Firstly, overcurrent protection coordination. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When coordinating overcurrent protection devices, it is important to ensure that the device closest to the fault will trip first, isolating the fault and preventing damage to other equipment. This is known as selective coordination. In the context of a tap ahead of the main service disconnect, the overcurrent protection device protecting the tap should be coordinated with the overcurrent protection device protecting the main service. This means that the tap's overcurrent protection device should trip before the main service's overcurrent protection device in the event of a fault on the tap circuit. This will prevent the entire facility from losing power due to a fault on a single circuit. Secondly, grounding and bonding. Grounding and bonding are essential safety measures that help to prevent electric shock and ensure the proper operation of electrical equipment. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Bonding connects all metal parts of the electrical system together, creating an equipotential plane that minimizes the risk of electric shock. In the context of a tap ahead of the main service disconnect, it is important to ensure that the tap is properly grounded and bonded to the main service grounding system. This will help to protect personnel and equipment from electrical hazards. Thirdly, labeling and signage. Proper labeling and signage are essential for identifying and understanding the different components of the electrical system. Labels should clearly indicate the purpose and function of each component, as well as any relevant safety information. Signage should be posted in prominent locations to warn personnel of potential hazards. In the context of a tap ahead of the main service disconnect, it is important to label the tap and all associated equipment to clearly identify its purpose and function. This will help to prevent confusion and ensure that the system is properly maintained. Fourthly, accessibility. Accessibility is an important consideration for any electrical installation. Electrical equipment should be readily accessible for inspection, maintenance, and repair. This means that there should be adequate space around the equipment to allow personnel to work safely and efficiently. In the context of a tap ahead of the main service disconnect, it is important to ensure that the tap and all associated equipment are readily accessible. This will allow qualified electrical professionals to perform routine maintenance and repairs without difficulty. Fifthly, compliance with other codes and standards. The NEC is not the only code or standard that may apply to electrical installation. Local building codes, fire codes, and other regulations may also have specific requirements that must be met. It is important to be familiar with all applicable codes and standards before beginning any electrical work. In the context of a tap ahead of the main service disconnect, it is important to ensure that the installation complies with all applicable codes and standards. This will help to ensure that the system is safe, reliable, and meets all regulatory requirements. Additionally, consider the potential for future expansion of the electrical system. If there is a possibility that the load on the tap will increase in the future, it is important to size the conductors and overcurrent protection devices accordingly. It is also important to consider the impact of the tap on the overall capacity of the main service. If the tap draws a significant amount of power, it may be necessary to upgrade the main service to accommodate the increased load. Another important consideration is the type of equipment that will be connected to the tap. Some types of equipment, such as motors and HVAC systems, can draw a large amount of current when they start up. This inrush current can cause voltage dips and other problems if the tap is not properly sized. It is important to take inrush current into account when designing the tap to ensure that the equipment will operate reliably. Furthermore, consider the potential for harmonics. Harmonics are distortions of the sinusoidal waveform of alternating current. They can be caused by nonlinear loads, such as electronic devices and variable frequency drives. Harmonics can cause a variety of problems, including overheating of equipment, reduced power factor, and interference with communication systems. If there is a significant amount of nonlinear load connected to the tap, it may be necessary to install harmonic filters to mitigate the effects of harmonics. When designing a tap ahead of the main service disconnect, it is also important to consider the impact on the safety of the electrical system. The tap should be designed and installed in a way that minimizes the risk of electric shock and fire. This includes using appropriate grounding and bonding techniques, selecting conductors and overcurrent protection devices with adequate ratings, and providing adequate clearances around electrical equipment. In addition to the technical considerations, it is also important to consider the cost of the tap. The cost of the tap will depend on a number of factors, including the size of the tap, the type of equipment used, and the complexity of the installation. It is important to obtain multiple quotes from qualified electrical contractors before making a decision. Before any work is performed, a thorough inspection of the existing electrical system should be conducted. This inspection should identify any potential problems or hazards that need to be addressed before the tap is installed. The inspection should be performed by a qualified electrical professional who is familiar with the NEC and local regulations. Also, a detailed load calculation should be performed to determine the amount of power that will be drawn by the tap. This load calculation should take into account all of the equipment that will be connected to the tap, as well as any potential future loads. The load calculation should be performed by a qualified electrical engineer or contractor. And before the tap is energized, it should be thoroughly tested to ensure that it is operating safely and reliably. This testing should include voltage and current measurements, insulation resistance tests, and ground impedance tests. The testing should be performed by a qualified electrical professional who is familiar with the NEC and local regulations. Finally, all of the work performed on the tap should be properly documented. This documentation should include detailed drawings, specifications, and test reports. The documentation should be kept in a safe place and should be readily available for future reference. By carefully considering all of these factors, you can ensure that the tap ahead of the main service disconnect is designed and installed safely and reliably. Remember to always consult with qualified electrical professionals when working with electricity.